A black hole is a region in space and time that is so dense that not even light could escape its gravity. Therefore, a black hole is an area in which the required escape velocity, the speed needed to escape a body's gravity, is faster than the speed of light. All objects with a mass have gravity, though the effect of this gravity can only be felt when an object is big enough, such as the size of a planet. The Earth's gravity prevents us and everything else on it from floating away into space, as well as fixing our moon into a constant orbit. The Sun's gravity fixes the Earth and all of the planets in our solar system to an orbit, and the black hole at the centre of our Milky Way galaxy fixes all those solar systems into an orbit as well. To put this into perspective, the Moon's orbit takes around 27 days. The Earth's orbit around the Sun takes 365 days, but the solar system's orbit around the centre of our galaxy takes 8.4 times 10 to the 10 days. To form a black hole, an enormous mass is compressed until it is infinitely small, which means that it still retains its mass and gravity, becoming extremely dense. To make the Earth into a black hole, it would need to be compressed down to the size of a marble, yet still retain its mass. This infinitely small region is called a singularity. However, in our observable universe, only stars 3 times the size of our Sun have been thought to have been turned into black holes. When stars run out of fuel and form an iron core, the gravity of a star becomes so strong that the star crushes inwards before exploding outwards into a supernova, releasing all its energy into space, leaving behind just the core that remains, that forms a black hole. Light and matter has no chance of escaping once it reaches a point of no return. This point is called the event horizon. This is why, inside the event horizon, there is nothing but darkness. Matter travels faster and faster the nearer it gets to this spherical boundary. Even the laws of physics are broken at the centre of a black hole. The very centre of a black hole is given the name singularity, where even time stops. Quantum physics meets general relativity at a black hole. But what exactly would happen to a human if it got near a black hole? From an onlooker's perspective, if this unlucky victim was wearing a watch at the time, the hands would appear to be ticking at a slower and slower rate. But for the unlucky victim's own perspective, the watch would appear completely normal. But never mind what the victim's Rolex says. What would actually happen to the human? Though many have thought that black holes would crush a person, instead, if you were to go near a black hole, you would stretch to death. But why is this? Well, if you were going head first, your head would reach the event horizon first. Therefore, your head would be experiencing much greater levels of gravity than your feet were, therefore stretching you apart. There are spinning black holes, elliptical black holes, and spinning elliptical black holes, and the variation depends on the amount of energy dispersed when distorting space and time. How would a black hole react with Earth? If a black hole was to find its way into our solar system, there'd be carnage. Firstly, the black hole would obviously have a much greater gravity than the Sun, therefore taking all the planets out of their orbits. The balance of the solar system would cease to exist. Asteroids would be ripped from their orbits too, being hurled at Earth. If that hadn't killed us all already, the black hole would suck up the Earth's atmosphere, and then the Earth itself. But maybe death by asteroid is a more pleasant way to die than dying by a black hole.